Hello guys, and welcome to today's daily Leetcode challenge. Let's begin question 1218, longest arithmetic subsequence of given difference. Okay. Given an integer array R and an integer difference, return the length of any of the longest subsequence in the R, which is an arithmetic subsequence such as the difference between the adjacent elements in the subsequence are equals difference. A subsequence is a sequence that can be derived from R by deleting some or no elements without changing the order of the remaining elements. Okay, so we're given on an input an array of integers, and we're given a integer difference. In that existing array of integers, we're asked to pick out some of the elements from that array whose difference consecutively is difference, what's given to us. So right off the bat, I can say that the most naive and the simplest to write solution would be to just do an iterative search over all the elements. So basically look at the first element, look at which next elements whose difference is the difference that's provided to us exists in the array, and keep track of that somehow. But the problem there immediately arises that you're doing an O of n squared iteration. You're essentially, for every element, you're going to be looking for the whole array. So it's going to be n, number of elements to start off with, times n, the number of elements in the array. So the time complexity of this algorithm is going to be O of n squared, and which immediately leads me to the next thing in my thinking process, which is how do we kind of reduce the number of calls on the second portion of that algorithm. So the first portion we can't really move away from. We have to be looking at the first element, well, at an element in the array, and then looking at what next element would fit our criteria of being the subsequence. But what we can reduce is having to look at all of them at the same time. What if we just look at the only one that fits our criteria in the first place? So for example, in the first case where we're looking at 1, in the first solution, in the iterative solution, in the simple, we would have to look at all of these elements to find the fitting subsequence. But what if we already have some sort of intermediate data structure that tells us that there's actually only one element that we care about, which is 1 plus difference? And so this leads me to think that it's a dynamic programming problem. Dynamic programming refers to a subcategory of problems here that basically ask you to build up the solution from or basically recursively define the problem early on in this problem, and then kind of the next element that's given to us, see if there's already exists a solution previously somewhere defined in our data structure. And so what I'm thinking now is, well, we need to start from the back, and we need to start looking at what are the longest subsequences that can start, given that we only have an array of 4. Well, what we need to keep track of is that 4 is the number that the subsequence starts from, and that can be done with a longest from number, and let's have this be a dictionary or a hash map, and that's it basically. Yeah, so now for cur num in reversed, and we can say r. Yeah, let's see, the next number is probably going to be what? The current number plus difference. But then what now? If next num, so if we're looking at 4, if the next number, which is 5, doesn't exist, is in longest from number, then we do something. What do we do? For now, we don't care. But else, if it's not, then we just say that, hey, longest number for our current number must be 1, right? But so what do we do in the case where the next number actually does exist? Next num, spell this wrong. Well, in the case that next number does exist, 5, what we would do is probably, okay, let's have a maximum integer, and let's say that this is the max of the longest of the current, in the case that current is actually already in the array. Like, for example, if there's a 1 and a 1, we have to see that if longest from number with next num actually beats the current num. So let's have this +1. So in the case that there was a 5 somewhere before 4, which we know there isn't, we would compare that longest subsequence +1 compared to what the most recent one is. There could be another, there could have been another 4 somewhere back there, which in which case this 4 wouldn't override that previous one. So now that we know the max, we can set the current number of cur num to m. And let's see if we're getting what we at least expect. There are some test cases that we can look at, and for this one specifically, I can be expecting a dictionary which goes 1 4 2 3 3 2 4 1. Okay, something is solution subsequence key error 3 does not exist in the longest from number, and that's because this is a dictionary, which means that if it's not in there, then you have to then there's going to be a key error. So there's something called the dict that I sometimes use, and passing it a type will return a default number, in this case 0. And perfect, we're expecting exactly what we want. For number 4, the longest subsequence is 1. For number 3, it happens to be 2. For number 2 is 3. For number 1, it is 1. Exactly as we wanted it. Okay, so now that we have this correctly set up, let's actually make another max subsequence. Let's have another subsequence, and just keep track of what is the longest subsequence, because the first one, number 1, doesn't have to be the longest subsequence, right? It could be somewhere down the line. So return max subseq. Oops. Return max subseq. Let's see if this passes. So yeah, this is a dynamic. It's definitely a dynamic programming question. Let's see if this works, and this is on the easy side. Sweet. Oh, and we got some new UI. Okay, so we're actually not that fast. We're actually on the lower end of fast. Let's see what this new UI gives us. Gives us some memory. Okay. Yeah, let's look at these better solutions. See if they're doing at least the same thing. They're doing a dynamic problem default dict with an int and for num and r. They're saying the dynamic problem is equal to minus the difference. Okay. So, I mean, for one, they're getting rid of this completely. They're saying, no, don't make this here at all, which kind of simplifies this. They're saying do this. Let's call this DP, as they were calling it. DP, a bit easier to read and less and this is what it's going to be in DP values, and just to make sure that this works, longest DP dynamic programming. Okay, so now the code is a lot less scary because there's less things happening. But okay, so what I thought they were doing here is that they were looking at the sequence, but from the other side. So they have a DP, and then for R and R, they're not reversing it. If there was a way of doing it. Yeah, for known, for DP, if for X and R, if known for X is going to be known X minus difference plus 1. Oh, so you don't even have to have the max here be calculated as we're doing here. It is absolutely given to us that this is going to be the solution. Yeah, I guess so. So then, yeah, let's not reverse it. Let's have this be an R. Let's not calculate next num or this at all. Let's just say that current number is going to be minus difference. And I have next num, but this is actually current num. Wow, so this is a lot simpler. I think I might have overcomplicated it, but to be completely honest, the solution that I proposed initially was not bad at all. And okay, we're beating 88%. Let's see if maybe we can use the max num somehow to because there's just no way that calculating the max over the whole thing is a faster approach than just doing this. Let's see if this works faster. Max num max. Oh, I'm not comparing it to the go. Okay, this is a bit faster. If it's not, then we'll just go with the, and it's not. And it's not. So this really is the fastest solution. And okay, so then in that case, I advocate for this. Feel free to copy and use this in your own solutions. I hope I explained everything correctly and thoroughly. the initial solution was kind of my real thoughts, but this is not too far away from the actual meaning. So the only difference is we're not reversing and we're doing it in order. And the reason why current minus different works is because it just so happens that the last element in the, which is like in our case, the 4 is actually going to be the last element. And you could find the subsequence by looking at it from the front too. You could say that this is 1, then this is 2, length of 2, this is length of 3, and this is length of 4. So same idea, just a bit adjusted. So cool, thanks for watching, and I'll see you tomorrow. Please like and subscribe.